very much for attending, everybody. We're certainly happy to be participating in eCOTS. It's such a wonderful conference and is well positioned during these difficult circumstances to be giving us content, lots of content, when we are stuck in these difficult times. So I'm getting a question about the going to full screen. I'm actually going to be flipping back and forth between several things, and I've discovered that it works a little bit better if I can see it like this. But let me know if this is going to be an issue. All right, thanks. So yeah, so today we are going to be thinking about open-ended data analysis collaboration in the intro stat course. And unfortunately, this is probably a more accurate title is going to be Open-Ended Data Analysis Collaboration in the Introductory Statistics course when all of your students and TAs are suddenly remote. So suffice to say, this semester, like all of yours, did not go exactly as planned. So we had an initial plan where we were going to run a set of pilot experiments on group collaboration on data analysis to learn how students work together. And what actually happened was a lot of panicking, some chaos, some deep breaths. We gave them some group stuff to do. We lowered our standards on what we expected was going to happen, and we were just aiming for making it to May, to be honest. But the good news is that we were still able to try out some group collaboration work, and we can report some of our anecdotal experiences for discussion. So we're hoping that this breakout session prompts a lot of discussion among the group about how we can promote these group activities for data analysis and what we might learn if we are to do other experiments or other activities in the future. So let's take a look at why we were even doing this or how we're going to interact during the session. So very quickly, there is a Google Doc, a shared sheet at group activity brainstorming with pros and cons at the address that you see there, the URL. Philipp, maybe you could put that in the chat for everybody, but it's a bit.ly that just goes to IL Collaborative. We're going to be using it a little bit later, but there are two main questions there. And the first is, what kinds of group activities do you use for data analysis in your classes, and what are the pros and cons? And then the other one is something that I know is a theme for today, what kinds of best practices and resources are available to teach people how to work in groups. So not the data analysis part, but the actual teaching people to work in groups. Then if you would like to participate in our subgroup collaboration exercise in a few minutes, please visit the below URL and sign up for an IL account. We're not tracking or saving your information. It's just for the demo. It's going to be removed afterward. And you do not have to do it to see collaboration in action, but just if you'd like to participate more fully, creating a fake account, you can use a fake name, email, etc. Just go ahead and give us sign up in the next couple of minutes. All right, thanks. Okay, so why are we thinking about this in the first place here at Carnegie Mellon? Well, we're actually doing a lot of thinking about the science of data science these days, or the science of statistics and data science. So the use and impact of data-driven decision-making, it just continues to grow and grow, right? We are supposed to be teaching our students how to make decisions using data. Well, and part of that is that we tell them and we preach these concepts that you must have reproducible or replicable results. Maybe those terms don't quite get used depending on the level that you're teaching, but it's this idea of when you are using data to make decisions, you need to have things be reproducible. I should be able to implement the same experiment or the same code, the same procedures on the same data and get the same results. We also have this notion of replicability that comes up. And here I'm thinking about obtaining consistent results across studies that are aimed at answering the same scientific question. So if you're thinking about a classroom, well, you're thinking maybe about one group of students doing a survey project, another group of students designing their own survey, or doing the same experiment, maybe on a slightly different population. And can we think about, do they get to the same results? Does an intervention, is it associated with a positive outcome? Something along those lines. The tricky thing here is for us is that all of this is made far more complicated by all the decisions that people make when they're doing data analysis. It's not so much about just the code and the experiments. It's about the decisions that we make. And these are decisions that aren't super well tracked. This is really hard for students to deal with. So here's just a quick example that we sometimes talk about. So when we're working with industry partners, or when students go out into the real world and they start thinking about how to use data science tools, they get this idea that they're just going to turn a crank, and that like some fancy machine learning black box AI algorithm is going to find all the structure and engineer all the features for them, and that that's going to solve all of their problems. And the reality is most of these decisions that get made in data analysis, these answers and results come from human subjective decisions. So here's one quick example. This is a one-dimensional graph of the velocities of 82 galaxies. This is a very famous data set, just 1D, simple to look at. And the idea is, if we see multiple groups in this data set, then that tells us something about the voids, the presence of voids and superclusters. Here's the tricky thing. In the upper left, I have a histogram that has the number of bins that I chose gave me about 3 modes or 3 groups. Now, if I look in the upper right, when I chose a smaller number of bins, I ended up looking like there's 1 group. And down in the lower left, if I decreased my bin size and I ended up with more bins, then now suddenly it looks like, I don't know, maybe I have 4. And if I chose a box plot, I wouldn't see any of this because I wouldn't be able to see the modality. So the issue here is something as simple as a graph choice is dictating what I'm going to do next. A lot of the algorithms and density estimation procedures and mode hunting and bump finding, all of these algorithms, a lot of them are based on density estimates. So if I slightly change my graph and my histogram, I'm going to get slightly different answers. And while there might be rules of thumb that help me choose those bin widths, at some point I just have to decide. I just have to pick graphs. I have to decide if I like my residual plots. I have to decide what I'm going to do next. And that's really the tricky thing. How do we decide things in data analysis? So what does this mean for students? Well, when we try to talk to our students about this, we get kind of probably similar things that you might get. So for example, when we think about reproducibility, they get the idea, well, I'm going to do the same steps I did last time. I'm going to get the same thing. But this is the kind of stuff we hear. Oh my God, I can't find my notes. I have no idea how I got this result. I think if we all kind of look back at our own research, we might think that as well. Students are like, I can't remember why I even chose this residual plot. I'm pretty sure it's because the professor or the teacher told me to. I don't know why I used this transformation. Should I change it? Is there a better one? And then we actually have had students copy their friends' answers in code and then say, but look, it's reproducible. So that's where it's been turned against us. And in terms of replicability, the things we hear all the time are the students being worried about, well, we got different random samples, but we did it from the same data set. I have slightly different results. So did I do everything wrong? Did the decisions that I made, did that lead to the problems? Like whose answers are actually right? We also hear things like, my friends have collected different data sets in a similar way, but we have same or different results. Who's going to fail? Who's getting the A? Is this right? Can you just tell me? A lot of times, this vagueness or this ambiguity is just really associated with students are making slightly different decisions, or they're dealing with randomness in the data. They're dealing with randomness in their distribution. And it's tricky for them to decide what to do because the randomness throws them, et cetera. But it comes down to the students having to make these decisions. Well, here's the other thing that we've been trying to think about, the joy and hell of group projects. So we want to teach our students how to do good data analysis, right? That's a very reasonable goal. But we also want to teach them how to work together. I mean, engaging everyone, this is crucial. We want everybody to be thinking about how could I collaborate with people who have similar backgrounds that I do? How could I collaborate with people who have different backgrounds? These are all crucial skills for moving out into the real world and applying statistics and data analysis to make data-driven decisions. This isn't even necessarily if they're going to be statisticians or data scientists. They just need to learn how to collaborate and think about data. And this has just made the problem 700,000 times worse, because now we have different sets of data analysis decisions, and they're coming from different people, and they have different backgrounds and different ideas. And somehow we expect that they're all just going to agree on one final product. So one question is, so what happens? Like, how do we actually do this? So if we could get a little bit of group help here before I start showing what we are trying to do. Let me get, if we could go to this website. And so one thing I'd like people to do, if they have a good data analysis activity, that's a group activity that's data-centric, that they think would be useful for the group to know about, it'd be wonderful if we could leave it in this Google Doc so that people could share from some wisdom here. So we're thinking about the description of activity. Are you working in K-12, intro, advanced? Is your small class a large class? And here are some things that work well, and here are some things that don't. So that would be, we can let that sit for a second, and people can add things, and then we'll come back to it. So let me go back to the talk. All right. So here's some of our experiences while people might be filling in things on the Google Sheet. So what we've tried is, and at Carnegie Mellon Statistics and Data Science, we're huge believers in working with real data, solving real problems. So they start working on real data in ISLE, the system I'll show fairly soon, like their 4th day of their 1st week of class. So we are big advocates in starting to work with real stuff, making real decisions, and working with others early. And as a result, we have a lot of good experiences with that and a lot of bad experiences. So we've tried having them sit and work in groups, right, during lab and class, as many of you have. And of course, we see the same things you probably see. Some of them talk to each other. Others stare at the laptop or the paper. Others wait until the class is over. So we see that there's just a question in the chat about the link to the Google Doc. If we could get that link re-put into the chat, that'd be appreciated. Thank you so much. We also have people working together outside of class. Now, I'm sure this is very different depending on what level you're teaching and what school you're at, but I'm guessing that you have somewhat of a similar problem. We have found it completely impossible to find times that groups of students can meet. It used to be that I didn't believe them when they would tell me that they could only meet at midnight in the Hunt Library. And then people started showing me their schedules and them trying to actually find a time they could all physically meet. And it was just unbelievably difficult. And some of that is due to, college lifestyles, and some of that is due to them having, wanting to be part of other student organizations, meeting at night, etc. But it's incredibly difficult. So we end up using a lot of class time because we can't find times for them to meet otherwise. And as a result, the students just end up dividing the work. There's no cohesion. And then, of course, we've all seen the 1 to 2 people do all of the work, and the others do the intro and conclusion. I'm sure we've all seen group presentations where somebody opens the project and talks for 2 minutes, then a bunch of other people maybe do a lot of the meat of the project, and then somebody concludes. And it is, I wouldn't say, I mean, it's a stereotype, but it's, in my experience, it's often the people at the beginning and the end have not put in much work in the project. We also have them use shareable tools. So they use Google, they use Slack, they do all kinds of group things. They're probably exchanging TikToks. I mean, they're doing stuff that I don't even know about. And one of the things that bothers us about this, it works okay, but it's very easy to ignore your group mates. There's not actually much interaction in terms of face-to-face. They're not often talking to each other. It also assumes that the students are all okay with downloading and running the tools, that they are comfortable with Slack, that they have the infrastructure, and that their laptops or iPads or library computers that they're borrowing all can run all of these things. That makes us nervous quite a bit because we worry about it being exclusive to some people who don't have the infrastructure or the background to be able to support using all of these tools. Not everybody has access to like the Google Classroom or to the what have you. So we've been trying to work on this. So how do we do this better? How can we do this better? The truth is, we don't really know what these students are doing. And it's kind of a little bit nerve-wracking. And we're not doing a very good job of teaching them how to optimize working together. So in the other group sessions that we've had today, we've seen some different ideas about how we can sort of try to teach them how to work as a group. Not the statistics or the data analysis, but actually working as a group. So we've tried things like group contracts that you might find from social and behavioral sciences, trying to give them information about how to optimize group, not just the group, like who's in the group. Some research has very interesting about gender, what gender breakdown leads to the most collaborative groups. We've had guest speakers come in and talk about the science of teams and the science of trying to optimize collaboration. And I saw some other really good opportunities. So if people if you're in the Google Doc, if you could please put some more suggestions for the group into what you've been able to do, or what ideas you might have, or what you've heard of, to try to think about how can we teach them the science of teams. Our experience has been just okay at this. It helps. We found it helpful to have students actually sign things that say that they understand what the group contract is. We also have had some success with doing peer reviews at the end, where during the peer review, each member of a group is supposed to say one thing that every other group member did well, and one thing that every other group member could improve. So we don't really couch it as like, this is something bad the group did, but an area for improvement. And we found often that the students are kind of reluctant to tell on each other unless things have gone really poorly, and then they sort of unleash. But they do try to be thoughtful in what's an area that people could improve. But we wanted to actually give them some data. So we thought, okay, all of these people are taking data classes. We want to give them data about how to analyze data as a group. And that's kicked off our new project in ISLE, which I'll look at in a second, about how to collaborate in groups. So what we're going to show you is something called the Integrated Statistics Learning Environment, or ISLE. And this is a project that supports, well, now it's supporting an awful lot of remote learning, but you can do lectures, sketch pads, you can do annotations, you can do statistical labs, surveys, there are widgets, there's peer-to-peer sharing. Let me just grab another screen share really quickly here, and we will go to ISLE. So if you come to this website, you can see examples of, there are data explorers, there are ways you can do remote videos. You can think about how to teach different kinds of models. There are widgets, for example, all the typical widgets you'd expect: confidence intervals, hypothesis test, working with distributions. All of these things exist, but it's fully integrated so that people can do chats, they can share materials, students can write annotations on lecture slides while instructors are giving those lecture slides. It's really fun, and because it's fully integrated, what we've been able to do is learn about how people are doing a data analysis and doing statistics. So let me go back to my slides. Okay, so at this point, what we'd like you to do is, if you do not want to create an ISLE account, you can go to the first URL that's on that sheet, isle.stat.cmu.edu/ecots/collaborative. And if you would like to see some of the group functionality, then you would go to the second one, which will require you to have made an ISLE account. Philipp Burckhardt, who is also a panelist on this particular talk, he is going to be randomly putting people into groups on that group website. So let's just check the chat here and make sure people are having, all right, great. So the URLs are going into the chat. But again, if you would just like to experiment with the collaboration, then please feel free to go to the first one. And if you would like to see the full group feature functionality, please go to the second one, which will require an ISLE account. And again, we're not saving anything for today's demo. We are simply just using it. You can create a fake account, it's fine. So the example that we're going to show you guys is our many student one data set study. And this is a version of the many analyst one data set study that was published a few years ago. That had basically, if you're not familiar with that study, they gave 29 research teams the same set of soccer data, and they asked them to determine if referees were more likely to give red cards to dark-skinned players. And essentially, the teams went off. They all worked on their data for a while, their analysis. These are trained statisticians, trained data analysts. At some point, they did peer review, and they swapped analyses. They got feedback from each other, and then they finished their analyses. And then this graph is showing how different the results were when 29 teams of relatively well-trained experts were analyzing the same data set. And the point here is that people just make different decisions. We have a group of analyses that all seem to kind of say, yes, there is a difference. There was the referees were more likely to give red cards, but we also have groups that didn't find significant results. And we have groups that found significant results, but with massive confidence intervals. And we found ones that had insignificant with small confidence intervals. So the variation was quite notable. And what we do is we give a scoped version of this to the students. All right, so let's take a look, and maybe I will pause. And Philip, if you can come off of mute, and maybe I will switch over my share screen to the collaborative groups.
So we are going to just demonstrate quickly this group activity now. So we have a lot of people sign up. So if you haven't signed up, like, we will pair people now. So maybe one more second, but since we are short on time, we should move forward. And then we will have these different groups, and there will be a collaborative report for people in different groups. So let's.
Philip, if you'll put me in a group as well, then I can start typing and show.
Okay.
All right, so whatever group I'm in, I'm going to start analyzing. I'm going to start analyzing data. Who is going to look at the box plots, for example? So I'm in the hyena group, so that's pretty great. I'd like to thank Philip for putting me in a good group. And I can come over and I can think about the toolbox. I can come here and I can I'm going to look at a histogram of how tall all the players are. And let's say I can do it by the red cards per game. And maybe I want to group by their skin tone. And I'm going to generate that graph. I'm going to hide the toolbox. I'm going to drag it over here. And so notice that when I floated my cursor over my graph, it saved the actions that I did to make that graph. And so what we have here is we have an opportunity to start interacting with each other. So what you'll see the students do, and we've watched this, is they all start talking to each other. I can turn on a text chat up here, and I can start talking to my group, and I can start asking them questions. I can start saying, hey, who's going to take care of this? I don't really understand that regression, et cetera, et cetera. And so what we can see is we start understanding the behavior of people, right? The behavior of how do they interact? We're saving their actions. We can see when they do it, which, by the way, for collaborative ones at night, obviously they all do it right before it's due. It's awful to watch. We see the decisions they make. We can analyze kind of the optimal actions if we think about performance for grades, et cetera. So I'm going to let that happen. I'm going to switch the screen back to the slides to show you some of the results of some of our engagements. But feel free to keep kind of playing around and seeing how the collaborative thing works. And if you have any issues, please feel free to put them in the chat, and we will try to address them as soon as we can. All right. So as you've seen, when we were just pulling up the collaborative thing, we can assign people to groups. They can chat with each other, and they can chat with the instructor and the TA. They can view each other over video. We did not turn that part on, or we didn't encourage that specifically for the last pilot that we did because we were having lots of issues with internet bandwidth for some of our students who were in less well-supported areas from an infrastructure standpoint. On the back end, we're tracking all the actions and the timestamps, you name it, so we can analyze when and how people worked, and we can tie this to their performance, but we also tailor instruction. So this is where because of the remote and the COVID-19 pandemic issue, this kind of threw off all of our experiments because we had this big, awful transition period in the middle of the semester, much as you did as well. But we'll tell you what we were able to do toward this end, and then tell you what we're doing next, and then answer questions. So we've been analyzing individuals and how they write data analysis and do data analysis reports. I'm happy to talk to anybody about that offline or maybe in another talk. And now we're starting to look at groups. So we ran a pilot in a computer lab of our introductory classes. We had about 100 students participate. IEL just runs in a web browser, so they didn't need to do anything except just open the website, no infrastructure, nothing else. We had 8 lab sections, and they were using Zoom and IEL to various degrees. Some of this was because the students were choosing to do different things. We didn't give them a ton of constraints on that because we were really just trying to get them to do it, and we were trying to learn from this experience. So some of them used the text, and some used audio and text to communicate. They discussed which analyses to undertake, but most worked independently on different sections of their report after they assigned the sections among themselves. That's not an unreasonable thing that we saw. We had people stretched from Hawaii to Korea trying to take classes together. Things were very difficult. We had anticipated that initially these experiments would be done with people working in the lab sitting next to each other, but for this first set of experiments, but of course the current situation changed that. So we asked them, like, are the collaborative editors in the group chats helpful? And they did say that they somewhat agreed. Some of them, they said they somewhat disagreed, and we'll see why in a second. Oh, sorry, first we have, how did the group divide the work? Well, very often they just did their different section and they worked independently. They did a different section, but they discussed their sections together. It's of course hard to know if that's because we're in remote learning or if that's because that's what they're going to do. So follow-up experiments, particularly as we navigate this new landscape, I think will help us learn more there. The results for the student feedback, we got lots and lots of feedback. We're only giving you a little bit of a snapshot. Happy to discuss more later if anyone wants to contact us. People thought it was good for collaboration. They had really strong opinions about if they wanted to use text and if they wanted to use audio. Some of them criticized that they couldn't use audio, but then the ones who did use audio didn't really use it. So we found that kind of interesting. They were pretty mad at their groups. They thought their groups needed to delegate the roles better. So that wasn't really about the IEL function. They liked being able to do that. They just thought they needed to do better as a group. And they really wanted to have it very obvious what was happening when things were being edited. They wanted to actually see each other's graphs all the time. Right now, we only have the functionality to share graphs and submit them back and forth, but they actually wanted to have the capability to actually watch each other work so that they could give feedback while they were doing it. So that's kind of a good feedback for us. But what we did see, and this is something to be thinking about as we move into this next phase of teaching, probably some remote, some hybrid, some in person, is that there's a mental tax, right, for having to switch back and forth between these different contexts, excuse me. So chat versus report writing versus data analysis. We're always having the issue of how to avoid students not participating. Well, we actually have the action logs, and if the students know they need to participate in order to receive a grade, we actually can tell them, we know how much you're doing. We have some students pushing back and saying, well, you know, how do you know I wasn't sitting next to somebody working with them? So you know, there's some nuances to think there. And also, how can we best help them learn to synthesize? So even if they work independently on different sections, how can we help them synthesize their work? So given after our kind of big transition to remote learning, what we're doing next is we're improving the collaborative editing experience, allowing it to be a little bit more searchable. Instructors can see all of this. They can see all of the actions. They can see all of the changes students are making. You can do this synchronously or asynchronously. Either is fine. We want to be able to give students feedback while they're working automatically. And we'd also like to do experiments where we compare different kinds of group assignments. So what's the impact of doing a random assignment versus doing that we let them get together in groups, etc. We're running more group experiments this summer and fall, And we also have some discipline-specific group activities. We had a poster this morning, and you can see it this afternoon. Please check that one out. And we're open for anybody joining us. I'm going to stop the share now so that we can see everybody, and I can get back to this chat. But in general, this aisle is available. Other people are using it, not just Carnegie Mellon. We now have this open-ended data analysis available, and you can now use it with groups of students. So if you're interested in joining us and learning about how students are working together on data analysis, please feel free to reach out at aisle@stat.cmu.edu, or you can check out the website at stat.cmu.edu/aisle. And I'll pause there and flip it to Megan. Thank you so much for your attention.
Hi, Rebecca. Thank you so much for your talk. We don't have a lot of time, but I just want to ask a couple of quick questions.
Yeah, sure.
Does this work within the learning management systems for a strictly online course?
So do you mean like, is it integrated with something like a Canvas or a Blackboard or something like that?
That's what I'm thinking they're asking.
Yeah, sure. No, that makes total sense. Yeah. So, and then Philip, can you put the email in the chat room? So, right now, what we're doing is we have aisle, and we have aisle running, and we have Canvas. So they are uploading their work to Canvas. But this summer, we're working to integrate them. So, for example, there's single sign-on authorization, and you can integrate Canvas and aisle. So, for us at Carnegie Mellon, at the other places that are using it, you still have to take your work, and if you wanted to submit your PDF of your report or something, you would submit it into Canvas. But I would say that's part of our next phase, where those will be integrated into common systems.
Yeah, so I guess this kind of goes along with that. How do students join aisle? Do you put them in, or do they elect to join? How does that part work?
Right, so right now, the students who are in the classes that are using aisle just create their own accounts. And so that's something that the instructor can manage. So we have instructors at other universities who manage it themselves. You can run aisle on your own server, for example. It doesn't have to be at Carnegie Mellon. We also have quite a lot of public data explorers that are actually just available. So students, don't technically have to create an aisle account to just use one of those public ones that they can find on the data set. You could write a report, hit convert to HTML, and just save your work, so that would be a way that you're not having to create an account. You wouldn't have to worry about anything like that.
Wow, that sounds really great. Thank you so much for coming to talk to us about this today.
Yeah.
Just really quick, what languages and applications were used in writing aisle? That'll be our last question.
Yeah, that's great. Philip, you want to come off on that
one?
Yeah,
just quickly on that. So it's all web-based technologies using like React.js, which is like a Facebook front-end library, and a Node.js backend. So with a MongoDB database. But basically what this means is that it runs on all web browsers, different types of devices, like laptops or like tablets, and should be kind of future-proof because it's built using like cutting edge or like current technology.
Philip, can you just say one sentence really quickly? We have a question about accessibility guidelines, and
yes,
I know that
so on that end, we are
right now.
auditing all our accessibility features and making sure that we are in compliance. So we are going through the process at CMU County to be approved campus-wide as a tool. And this hopefully should be concluded by the end of the fall. So if people are end of the summer, so for the fall. So if people would be interested in maybe giving it a shot in the fall, we should be ready by then from an accessibility standpoint.
Wonderful. Thank you both very much.